Now we need to simplify this expression. Whenever we have expressions of this form, the first thing we do is to break this in terms of their prime factors. And then we can simplify it using the laws of exponents which we have learned. So 12 is equal to, now we have 12. 12 can be written as 3 into 2 into 2, which is equal to 3 into 2 square. So we can write 12 as 3 into 2 square and 12 raised to the power 4. So we write it to the power 4 into 9 cube. Now 9 is 3 square. So this is 3 square whole to the power 3. Negative 2 can be written as negative 1 into 2. And this whole to the power 2. So this is what we have on the numerator. This entire thing divided by 6 cube. 6 is 3 into 2. So 3 into 2 whole to the power 3 into 8 to the power 2. 8 is 2 cube. So 2 cube whole to the power 2 into negative 3 cube. Negative 3 is negative 1 into 3 to the power 3. So this thing whole to the power 3. So this is what we have on the denominator. We have written down everything in terms of its prime factors. So this is what we have. Now we know that if we have a into b to the power n, we can write it as a to the power n into b to the power n. So now this into this whole to the power 4 can be written as 3 to the power 4 into 2 square to the power 4. 2 square to the power 4. Now 2 square to the power 4 is equal to 2 to the power 2 into 4. 2 into 4 is 8. So this is equal to 2 to the power 8. So into 2 to the power 8 into 3 square to the power 3. 3 square to the power 3 is equal to 3 to the power 2 into 3. Now 3 to the power 2 into 3 is 3 to the power 6. So we have 3 to the power 6 here into negative 1 into 2 whole to the power 2. So this gives negative 1 to the power 2 into 2 to the power 2. This is what we have on the numerator, divided by 3 into 2 to the power 3 is 3 to the power 3 into 2 to the power 3 into 2 to the power 3 whole to the power 2 is 2 to the power 3 into 2, which is 6. So this is 2 to the power 6 into negative 1 to the power 3 into 3 to the power 3. So this is what we have. Now we can club some of these. When we have the same base, then the powers get added. That is, if we have a to the power m into a to the power n, you can write it as a to the power m plus n. So we can write it as 3 to the power 4 into 3 to the power 6 as 3 to the power 10, 2 to the power 8 into 2 to the power 2 as 2 to the power 10, and we have negative 1 to the power 2. There is no negative 1 in the numerator, but there is negative 1 to the power 3 in the denominator. Now, if we have a to the power m divided by a to the power n, we can write it as a to the power m minus n. So when we have the same base, we can subtract the powers. So negative 1 to the power 2 divided by negative 1 to the power 3 can be written as negative 1 to the power 2 minus 3. That is negative 1 to the power negative 1. This means this is 1 divided by negative 1. So we have a negative 1 in the denominator. Now in the denominator, we have 3 to the power 3 into 3 to the power 3, which is 3 to the power 6, into 2 to the power 3 into 2 to the power 6 is 2 to the power 3 plus 6, which is 9. So this is what we have. Now again, we apply a to the power m divided by a to the power n is equal to a to the power m minus n. So when we have the same base, we subtract the powers. So 3 to the power 10 divided by 3 to the power 6 will give us 3 to the power 10 minus 6, which is 4, into 2 to the power 10 divided by 2 to the power 9 will give us 2 to the power 10 minus 9, which is 1. And we have a negative 1. So we put a negative sign here. So this is negative 1 into 3 to the power 4 into 2 to the power 1, which is equal to negative 1 into 3 to the power 4 is 81 into 2, and this is equal to negative 162. So this is equal to negative 162. So this is the solution, or this is the value of this expression. We can derive it by first writing the expression in terms of its prime factors and then simplifying it using the laws of exponents. Now we need to simplify this expression. So we have this minus this divided by this minus this. So first we need to see if we can take anything common from the two expressions in the numerator, and if we can take anything common from these two in the denominator. In the numerator, we have 5 to the power something minus 6 into 5 to the power something. So we have some power of 2 in both these terms. So we can take that common. Now we take the highest power of 5, which is present in both the terms, as common. So what is the highest power of 5 which is present in this term as well as this term? We have 5 to the power n plus 2 here. We have 5 to the power n plus 1 here. Now clearly n plus 1 is less than n plus 2. So the highest power which is present in both, that is, which is common to both, is 5 to the power n plus 1. So we take 5 to the power n plus 1 as common, and then this becomes, now 5 to the power n plus 1 into what will give us 5 to the power n plus 2? So we have already taken n plus 1 here. We need n plus 2. That is, we need 1 more. So this should be 5 to the power 1, because this into this will give us 5 to the power n plus 2. Now in the second term, we have 6 into 5 to the power n plus 1, which we have already taken common. So this is what we have in the numerator. Now again, what is the highest power which we can take common from both the terms? We have 13 here, but we do not have any 13 or any of its multiple here. We have 5 to the power n here. We have 5 to the power n plus 1 here. So 5 to the power n is common to both. We have 2 here. We do not have any multiple of 2. So we take 5 to the power n common. So 5 to the power n is taken common. And we are left with 13 minus 2 into 5. Because we have 5 to the power n plus 1. 5 to the power n is already taken out. So we'll be left with 5. So this is what we have. Now we have 5 to the power n and 5 to the power n plus 1. So we cancel out the common part. Now 5 to the power n plus 1 divided by 5 to the power n is equal to 5 to the power n plus 1 minus n. Because when we divide two exponentials with the same base, their powers are subtracted. And this gives us 5 to the power 1. So we'll have 5 to the power 1 here into 5 minus 6, which is negative 1. In the denominator, this 5 has already been cancelled with this. 13 minus 10. 13 minus 10 is 3. Now this gives us negative 5 by 3. So this is the solution, or this is the simplified form of this expression. We see that although we had an n, all the n's get cancelled among themselves, and finally we are left with this constant term, which is negative 5 by 3.